Maurice.
So where is that declared in the beginning?
Which?
The strut error.
It's not.
It's not.
Error is declared in one of those libraries up there.
Okay. That's
Okay, the operating system, anytime you make any, because I'm compiling it with wall, if you compile it with wall and you don't have the right # include up there, the operating system's going to whine at you.
So Dr. Morris, will it actually put, is it going to actually put what's in the library, or is it going to put?
It's going to tell you, it's going to say something like, error invoked with no prototype. Okay. Then what you would do is you would go to your command line, you would go man error. And up would come the manual page, and it would go error, include standard live, or wherever it's declared.
Okay.
Okay, so wall not only is a useful thing in terms of getting the compile, but it also helps you start to understand where all these operating system library calls live. What header files they live in. That's what the .h's are, they're header files. Okay, so assuming this is good, then what do you suppose the remove operating system function does?
Remove the file.
It nukes the file. And then we return
Exit
0. That means everything's cool. No errors. All right? So ls. So let's see. How does ls work? So here's an example. I go ls. In this case, I've got arguments to it. -la.
It's going to list something, right?
So yes, we're going to do a watered down version. We're not going to be able to send all these fancy argument, LA and LAI and yada yada. We're just going to go ls, and it's going to go to the current working directory, and it's going to pull up a listing of everything in that current working directory.
Dr. Moore, just for my knowledge, what did LA mean?
It's the one that gives you the timestamps, the permission bits, and all that.
Okay.
So here is, so if I just come along and I go ls, do you see what I get?
Mm-hmm.
I just get a listing of all the files. Okay? Listing of all the files. So many columns wide. Okay? Now if I do something like ls-la, then I get an entirely different picture. Okay, it shows, like, to the left all the permission bits, read, write, execute for user group others. It shows, I think this is the number of blocks. This is user group. This is the number of bytes, timestamp, file name. All right, and then if I did ls-lai, I means show me the inode numbers. So here, it turns out that, notice that it includes dot and dot dot. So what's the inode associated with the current working directory?
476.
No, it's 182793031. That's its inode number.
Oh, okay.
Okay? So there's just 100 different permutations of the ls command depending on what it is you're trying to do.
So ls-l.
Well, let's try it. So ls-l. So doesn't include all. The A is include hidden files. The L is long. So ls-la is long all.
So it doesn't include the inode.
It doesn't include, well, the inode is the I option. ls-lai. If you want to know how it works, you go man ls. And it brings up the man. It goes, here are your options.
I didn't know it did that.
That's what I told you the other day, a man. And then now every option that you want, okay? Every option you want, explains all of them. Boom, binary, blah, 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 blah.
Is that what
any Unix command, man, command name, the whole 9 yards. If I didn't know what error was,
just say man?
okay, there it is. Where's it defined? What # include do I use? Synopsis. Standard.io.h. What's the call look like? Error. Num. Everything. Gives me everything I know. How does printf work? Man. printf. Okay, there it is, and there's several of them here. Okay, so what's it? Printf format arguments. Okay, so it turns out that there's several printfs. Okay.
This is just a lucid question, and you probably would know that. Do all of those most of the languages have that printf? I know Java does, but
It has-
does
it's-
Fortran?
Java and C are related.
The C
They- Java and C, MATLAB, a lot of languages mimic C syntax. It's not unusual. Fortran has a similar capability. It's not printf, but it has a similar capability. Most languages have either directly or through a library some I/O capability.
Okay.
All right, so moving then, back over to where we were. Good. So we're looking at LS. We're just going to do vanilla LS. No LAs, no LAIs, no Bs, nothing. Just show me columns of files. All right? So because we're implementing what version of LS? A watered down
Version.
A watered down version. So here we go. So question. LS, how many arguments?
one.
Yeah, only the command, right? In our watered down example. So notice that my main on line 19 doesn't need command line arguments. It's just int main void. I don't need command line arguments for watered down
19.
LS.
Because there is no commander.
There are no file names or whatever. So there's nothing.
What is line 14?
Well, we'll get to that. So let's start up at, so notice that I'm using this function called scandir. How would I know how scandir works?
Man,
I'm gonna take it
Man scandir.
It's a scan.
And it would tell me all about it. And it'd say, well, you have to include dir int.h, blah, 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 blah. How do you learn all this stuff?
Right.
You practice, playing around, looking at well-written code, sometimes looking at poorly written code. Learn how not to do stuff. Okay?
Is scandir prompting the user?
No, so I'll explain scandir in a minute. So line 14 is a local function that simply prevents the entries dot and dot dot from being included in the listing. Remember, if I do just ls, does it show dot and dot dot? No, that required an LSA.
Hey.
Now, right? So since I didn't do LSA, ls-a, I don't want dot and dot dot. So this selector function limits what scandir does. In particular, it says don't include dot dot dot. That's all it says. Now here we go. So line 20, 21, and 22 are declarations. If you were to do a man on scandir, you would see that what it wants right there is going to be a handle to one of these objects of type struct dirint. Okay? It's that simple. All right, so I declare my objects, then I say n gets scandir. And notice what it wants. It wants, what do you suppose the first argument is?
The count? No, I is 0.
In scandir, what do you suppose that first argument corresponds to? Dot. What's dot normally? Here, which is current working directory. So I want you to scan the directory here, this directory. Where do you want me to put the file names that I find? In the thing called list. Okay? Then, which ones do you want me to exclude?
Dot and dot dot.
The ones that select O tells you to exclude. Okay? And then finally, what kind of sorting do you want? An alphabetic sort. Okay?
Now, Doctor, why don't we initialize the list? As an end, because after.
You didn't. You initialize it, it's not initialized, it's a struct durend star list.
No, we're not doing it because we're not getting a value for it, right? I mean, we're not.
The only time you need to initialize something is if the initialization is required, say a counter. Where do counters start?
0.
Yeah.
0, right?
And L is not counting anything.
It's not
only-
counting anything.
It's just giving us a
In
list.
some sense, you have to initialize a file pointer. How do you do that? By using fopen.
Okay.
You see it's a subtlety, right?
Dr. Morris,
Yes.
I know dot is here, and I heard you say dot is here.
That's,
but,
yeah, that's our friend here.
but what does dot actually mean?
It means parent.
Okay.
So again, what do you suppose N represents?
It's just a name.
The number of items in the list.
Okay.
Okay? So now I've got this list. What do you suppose I'm going to do with that list?
You got
Print it out.
in alphabetical order.
Okay? Well, it's already in alphabetical order. And all this hokey pokey here does is puts it in columns. Okay?
Okay.
Every third column it puts a new line. So file name, new line. File name, new line. File name, new line. Like that. That's all this is doing.
Where's that happening?
At the
Right
bottom.
here, in the if statement. You see, this is the modulo operator. Modulo operator, what's 4 modulo 2?
2
2.
0. The remainder,
is 2.
right? What's 9 modulo 3?
0.
Right? So I modulo calls, and if you look, what's calls defined as?
Calls.
3,
Oh,
right?
that's it.
So
Right.
I modulo calls says, if it's some multiple of 3, then what do? Line 29.
Let's go to the next
Print
one.
Print a
out
new
the
line.
line.
And then no matter what, print out list of ID name, the name of the file.
So 4 is actually counting, so it could give you put the information into the modulo spot, so you'll know how many lines to print before.
I know how many columns it is.
Okay.
Then you have to know that scander allocates the list and you have to free it. How would you know that? Man scander.
But why do we have to free it?
Because otherwise it's a memory leak. You've allocated memory from the operating system and then not returned it to the free list. That's what causes a memory leak. And eventually that's what causes your Windows to BSOD, blue screen of death, and all these other things, because I'll only use the first adjective, okay? Lazy
Programming.
Okay, I'll just use the first acronym, the first adverb.
You could have used a letter.
So if you don't do the free list, that list is gonna basically keep.
It's the memory that was allocated is still going to be allocated.
Right.
Unless this implementation of C happens to be nice enough to know that when this process called WDLS disappears, deallocate all of its memory. Okay, and that's where you get these lazy programmers. Well, it's always done it in the past, so I'm going to start writing embedded code and crash the airplane because I'm a moron. And no biggie. So what? A school teacher dies.